Hey there, physics class. Welcome back to another day. We've got just a little bit more time left. Sorry if my video is kind of weird at the beginning here. I don't know what the deal is, but whatever is supposed to happen is not really working out too well. I want to spend um, today, just in this video, this short video here, talking about the three problems from yesterday. So, number one, let's just jump right in. A 12-volt storage battery is connected to three resistors, and then it gives you the resistances there. The resistors are joined in series. Okay, so they're lined up all together. So, two parts: calculate the equivalent resistance, and then what is the current in the circuit. So, I'm going to try to do this online. Let's see if this works out. It may fail miserably. Let me get my phone out to be my calculator. Um, so I'm trying it on this app because I tried another one yesterday and it didn't work at all. Um, let's see, calculator. Okay. All right. So I already forgot what the circuit was like. Okay. So sorry if you see my hand up here. I'm writing. Um, you probably won't. All right. So the first thing you need to do is draw the circuit. So it's got a battery. Okay. Oh, this is tough. That's not too bad. All right, and you can draw the circuit in a number of ways. That's not great, but it's fine. It's got three resistors, 6.75 ohms. Okay, that's one. And then you got 15.3 and 21.6. And please don't make fun of me for my bad handwriting. It's hard to do on here. And then it was a 12, it was a 9-volt battery or 12? 12 volt. So I'm going to write the voltage down there. Okay, so the part A, it asks you to find the equivalent resistance. And so remember, so for part A, I should probably do this in a different color. We want to find the equivalent resistance. All right, and so to find the equivalent resistance, remember we add all the resistors together. So R1 plus R2 plus R3. Okay. Oh, thanks. Don't let it go to waste. No. Okay. So we're going to add all those up. That's really simple. I don't even have to write that down. I'm just going to add 6.75 plus 15.3 plus 21.6. So the equivalent resistance equals 43.65 ohms. And of course, you can round it to the closest three digits here. So 43.7 is fine. So what that means is we're now going to, oh, this is cool. Oh, sweet. Oh, yeah. Oh, that's nice. Okay, so I'm going to redraw our circuit, but I'm going to redraw it. Oh, okay. Whoa, I got to get used to that. I'm going to redraw it over here. You don't have to do this part, but I like to do this because we've now found the equivalent resistance. So basically, we have a very simple circuit now. I need to select that again. So now, oh man. Okay, use the thingamabob. Okay, there we go. So now our circuit is the 12-volt battery, but basically we can say just one resistor. It's equivalent to saying instead of all three of those resistors, now we can say, well, all three of those resistors really add up to just being 43.7 ohms. So it's basically like a circuit with one resistor. And now when we want to find, so for part B, when it asks what is current, the current is equal to the voltage over the resistance of the circuit. And so that means the equivalent resistance, really. So when we plug this in, that's going to be voltage is 12 volts and the resistance 43.7 ohms. And so the current going through this whole circuit is 12 divided by 43.7. So about 0.275 amps. And that's it. That's what we do to find the equivalent resistance and current. That means this current is going through each resistor. So each resistor has that current going through. Current doesn't build up in one place and get trapped and jammed. Current goes through all the resistors equally. When there's only one path for the current to go, the current is the same speed throughout the whole circuit. So it's going to be 0.275 amps through the first resistor, 0.275 amps through the second one, 0.275 amps for the third one. Okay, so that's all it is. It's the current is going the same in each resistor. Okay, so let's go to the next problem here. Can I get a new board? Oh, is this? No. What's this? No, I didn't do it. You know what? Why don't we just move it on over here? Okay, let me zoom in a little bit. I messed up big time. Okay, here we go. All right, and now let's do number 2. So number 2, it says we got a 4 ohm resistor, 8 ohm resistor, and 12 ohm resistor connected in series with a 24 volt battery. Calculate the equivalent resistance, the current in the circuit, and then what is the current in each resistor. So I'm going to draw my circuit again. And you could draw the circuit in different ways. So I'm going to show you another way to draw it. You might prefer this one. I don't know. So when I draw this one, I'm using the pen. Why is it still selected over here? Please forgive my mistakes and ignorance. Okay, here we go. Oh, wow. Let's redo that. So that's the battery, right? That's the symbol for a battery. And how much was the battery or the, okay, 24 volts. Sometimes this is called an EMF source, electromotive force voltage. It's just basically the voltage source, the power supply. And we have 3 resistors, so you could draw that like this if you wanted to. Maybe you prefer it this way. That's the same as the other one that we did before. The other one, I just put the resistors on the side, but this is the same thing. Okay, so I'm going to add in our resistors here. So we had 4, 8, and 12. So that's going to be 4 ohms, 8 ohms, and 12 ohms. So already I can add those together and tell you the equivalent resistance is going to be 24 ohms. So that's really easy. Okay. For the current, I think I did current in red last time. So for the current, that's going to be the voltage over the total resistance. So that's going to be 24 volts over 24 ohms. And that means that the current through the whole circuit here okay, back to this, is going to equal 1 amp. So exactly 1 amp. And part C asks, what is the current in each resistor? Now, I kind of gave you a clue on this last time. The current in each resistor has to be 1 amp. They're all 1 amp because it's just one path for the current. So because there's only one path for the current, oh, that kind of looks like a switch right there, but it's supposed to be connected. Because there's just one path, the current is going to go the same speed throughout that whole path. And so each one of these has a current of 1 amp going through them. Oh, come on. I don't know what the deal is with this. Okay. So each one has a current of 1 amp going through. Okay, now I want to just add one thing today because your assignment today is going to add something new. And so I'm going to add a question to this one. I want to know, how much does the voltage drop after it goes through each of these resistors? So whenever current goes through a resistor like this, it loses some of its potential energy. It gets used up. So that voltage energy gets used up in the resistor, and so it starts out over here at 24, and then it ends at 0. And so throughout that process, we should see that the voltage will drop each time it goes across one of these resistors, and at the very end we should end up with 0. So let's see how much the voltage drops each time. Remember, voltage equals the current times the resistance, right? So to find the voltage drop across each resistor, let's look at the 4 ohm resistor first. So the voltage drop here is going to be the current, which is 1 times 4. All right, so the voltage drop there, the current is 1 amp, the resistance is 4 ohms. So the voltage drop there is simply, I'm just going to erase that and say 4 volts. Okay, here for the middle resistor, I'm pointing at the screen, but you can't see that. 8 ohms times 1 amp, so current times resistance there is 8 volts. And then here, current, the last one, 1 amp times 12 ohms of resistance, that's 12 volts. So if you notice, if you add up all the drops in voltages, they also add up to 24. Now, the current's not always going to be 1 amp here. So it might have different kinds of numbers. It's not always going to look exactly the same because here we multiply by 1. But what you're going to see is each time the current goes across a resistor, the voltage will drop. Number 3, I think I did number 3 just now. Yeah, so that was number 3. Because the current in the equivalent resistor of sample A problem is 0.5 amps. Oh, no. Okay. Sample problem A was the one that... Let me find that real quick. Sample problem A. All right, so sample problem A was from the video from yesterday. And so it gives you all the different resistors here. And it said that the current is 0.5 amps, as we discovered yesterday. So to find the potential difference across each resistor, remember potential difference is another word for voltage. So to find the voltage across each resistor for this third problem here, that would be voltage equals IR. Remember V equals IR. So to find the potential difference across each of these, the voltage will be equal to the current times the resistance. So the voltage across the first resistor is going to be 0.5 amps times 2 ohms. So voltage 1 is 1 volt. Okay, and I'm going off of what I see right there, right? Because that's the resistance 1. So then we go to resistance 2. So the voltage V2 is going to be 0.5 amps times 4 ohms. And so we find that that would be 2 volts. So the voltage drops 2 volts across that resistor. And so the other one, so for resistance 3, it's going to be 0.5 times 5, so that would be 2.5 volts. And then for resistance 4, it's going to be 7 times 0.5, so that would be 3.5 volts. All right, so if you added up all of these different voltages here, so we got 2.5, 3.5, 2, and 1, let's see, you would get 9. And that's what we started with here. So it does actually work out. So that's number 3. Sorry that it's all messy on here, but that's how you find number 3. So good luck on today's. I gave you 3 more questions to do today. They have to do with this second method here. But remember, you always have to find the equivalent resistance first so that you can find the current that goes through the whole circuit first. When you know the current that's going through the circuit, that current is going to be the same at any point in the circuit, and then you can use that to find the voltage drops across either. So please reach out if you have any questions. This has the potential to be very confusing. So let me know if you have any questions.